Okay, guys, it's Mrs. Millicent. We're going to do the check your understanding on page 711. Okay, Canada has universal health care and the United States does not. How did the two systems compare in treating heart attacks? Researchers compare random samples of U.S. and Canadian heart attack patients. One key outcome was the patient's own assessment of their quality of life relative to what it had been before the heart attack. Here's the data for the patients who survived a year. Okay, we're not going to do the graph. Is there a significant difference between the two distributions of quality of life ratings? Carry out an appropriate test at the 1% alpha level. Okay, so this would be, you would think, you've got all these proportions, you kind of got all these values to compare. So if it was just one rating, we could do, I don't know, one proportion or a two proportion z-test or a two sample t-test, but you've got too many proportions, okay? Plus it's two distinct samples from two distinct populations. Sometimes a chi-square test for homogeneity has one big sample, but it's broken up in two different categories, okay? But it can't be a goodness of fit because it's not like I'm just comparing Canada to some other parameter or the United States to some other parameter. So it's got to be a chi-square test for homogeneity. Okay, I went ahead and retyped this up on another piece of paper so I could write all over it, okay? So here we have it, and of course I've pre-written stuff. So this is page 711. Check your understanding on page 711. Okay. So of course we had our table. The first thing I'm going to do is all of my totals, because anytime you have a table, do your totals. Okay. So let's do our hypotheses. So just like most null hypotheses, the hoe is that there is no difference. Okay. So I'm just going to say there is no difference in the distributions of quality of life ratings between Canada and U.S. So that's my null hypothesis. And of course, my alternative hypothesis, my ha, is that there is a difference, okay? And of course, it told us to use an alpha of 0.01. Hey, these are heart attack patients. That's pretty sensitive, so we'll use a nice sensitive alpha value. Okay. Then we go through our plan. Of course, this is a chi-square test for homogeneity. We know our conditions, random. It did state that these were random samples of U.S. and Canadians. So I stated two random samples of U.S. and Canadians was taken. Independence, 10%. All right, I did two of them because I actually had a sample of Canadians and a sample of U.S. patients. So I went ahead and did my 10% for both. So I'm pretty sure there's more than 3,110 Canadian patients and more than 21,650 U.S. patients. And of course, all patients are independent. All right, large counts. Can't make a statement until I actually calculate my large counts, all right? So let's do one or two by hand, and then we'll run it in the calculator, okay? So again, how you do your large counts is we have to look at our expected counts. So we'll do the Canadian much better. So we're going to do row total. So let's see, 16 times column total divided by table total, and of course I'm going to hit math des for decimal, okay, and we get 77.4. Check my thing. Okay, so 77.4. Let's do this one. Let's do the U.S. somewhat worse, okay, so our row total is 332 times my column total, which is 2165, over my table total. And of course, I'm going to turn it into a decimal. And I get 290.3. And that was down here, 290.3. So I'm just going to create another table that has the same markings. I abbreviated much better, somewhat better, about the same, somewhat worse, much worse, and then my Canadian US. Okay, I'm not going to do all of those by hand. I'm going to run them in the calculator. So how do I run it in the calculator? I have to put my observed in my matrix. So let's go to, let me move this up so you can see. Second matrix, and I'm going to edit and create matrix A. I have, let's see, 5 rows and 2 columns. So let's get this stuff in. 6, 7, 9. I lost track. 282, 19, and 65. Make sure everything looks good. Yep. Okay. Now I'm just going to run my test. Chi-square test, because remember this is tests for independence and homogeneity. Got my observed in matrix A. I'm just going to calculate. I'll run it again to check my p-value and all that stuff. So let's go back to the matrix, and now I'm actually going to look at matrix B and get my expected counts. I already got the 77.4 and I already got the 290.3. I'm just going to fill in the rest. So let's see, 71.5, 109.9, 41.7, 10.6, 538.6, 497.5, 765.1, and 73.4. Okay? So you don't have to do them all by hand, but know how to do them by hand because you'll see that question in a multiple choice probably. Okay, all those expected counts greater than 5? Definitely. Okay, so we're good to go. Let's go ahead and write out our chi-square statistic here. And again, I got to show a little bit of it. I don't need to do all 10 of them though, thank goodness. So I'm going to do the first 2 and the last 2. So let's see. My actual up here is 75. Whoops. Minus 77.4 squared over 77.4. I'm going to go this way. So 541 minus 538 squared. That looks a terrible 3. And then I'm going to do my last 2. So let's see, 19 minus 10.6, and then 65 minus 73.4. Oh my gosh, my 3s are looking terrible. Okay, so I've showed enough of my equation. I'm not doing the whole thing by hand. I'm going to run the calculator, run the test to get in the calculator. Okay. I wish I could have remembered what it was. I should have written it down. All right, let's run the test in the calculator. Sorry, I got the glare from the light. Stat tests, chi-square test. Okay, so my chi-square statistic is 11.7. My p-value is 0.0195. My degree of freedom is 4. Okay, so I've got 11.73, p-value 0.0195, and degree of freedom. Okay, don't forget degree of freedom is the number of rows minus 1 times the number of columns minus 1. Number of rows is 5. Number of columns is 2. So that's 4 times 1, which is 4, and I agree with the calculator for my degree of freedom. Okay? All right, let's test our p against our alpha, and we're almost done. 0.0195, our alpha was low. So is that true? No, it is not. Okay? The p-value 0.0195 is not less than alpha of 0.01, therefore we fail to reject the HO. So I do not have convincing evidence. I do not have convincing evidence that there is a difference in the distributions of quality of life ratings between Canada and the U.S. Okay? So there is my conclusion, all nice and written out. Okay? All right. That's it for this one. See you next time.